Alright, let's go through the sample test. We'll start with number 1 here. It says find g of f of 0. So that means put 0 into f, and f is 5 times 3 to the negative x, and so it'll be negative of 0, and what we get for that is anything to negative 0 is 0, 3 to the 0 is 1 times 5 is 5, and so we got to take g of 5, and g is 3 times negative 3 minus negative 5 times, and since we're putting in 5, it'd be 5, so we get 3 minus 25, which is negative 22. Number 2, or B, says g of f of x. So we got to put f of x in place of g, in place of the x in g. So g is, so g composite f of x. So we got to put f of x, which is 5 times 3 to the negative x, and we're going to put that in place of the x's of the other. So we got 3 minus 5 parentheses. In place of the x, we're putting 5 times 3 to the negative x. Now, this 3 is to the negative x, so we can't multiply the 5 times the 3 because this has got a power that's got to happen before multiplication according to rules of order. But these 5's can be multiplied, so this can become 3 minus 25 times 3 to the negative x. Okay? Now let's go to the next one. H inverse of x. Well, h was just these 4 points, and the inverse is the points reversed. And so that would be, instead of 1, 2, it'd be 2, 1. That's what it inversed. If h takes 1 and makes it a 2, the inverse has to take the 2 back to a 1. It would take, if h takes 2 to make it a negative 11, then the inverse takes negative 11 and makes it 2. If h takes 4 and makes it a 2, then the inverse takes a 2 and makes it a 4. And if it takes a negative 1 and makes it a 5, the inverse would take 5 and make it a negative 1. Now it turns out this is not a function because now we have 2 going to 1 and 2 also going to a 4. So h did not pass the horizontal line test, so it doesn't, the inverse isn't a function. Now let's find the inverse of g. G was equal to 3 minus 5x, g of x is, so that's y equals this, and so we switch the y and x, so we'll say x equals 3 minus 5y, and solve for y, which would be the inverse. So we're going to have to subtract 3 from both sides, so we'll have x minus 3 equals negative 5y, and divide by negative 5 on both sides, and so we'll get x minus 3 all over negative 5 is y, and that's what the inverse would be. So g inverse of x would be x minus 3 over negative 5. Or it could be, you could call this negative 1/5 times all this and make it negative 1/5 x plus 3/5. That's another way to write it. Okay? E says determine g of h of x. So since h only is 4 points, then we're only going to get 4 points out of this. And so this is going to be a set of points. And the first thing that we can put into h is 1. And it comes out as a 2. But then that what comes out has to be put into g. So we started with a 1, put it into h, got a 2. We put a 2 into g, and that would be 3 minus 10, which is negative 7. Now the second thing we can put into h is 2. And so if we put in the 2, h will turn that to negative 11. Negative 11 into g would be negative 5 times negative 11 would be positive 55, and 3 is 58. And now we can put in 4. 4 goes to a 2 again, so that's going to come out to be negative 7 like the other one did. And finally, we're going to put in the last one, which was negative 1. And that's what h changes that to a 5. And 5 into g is 3 minus 25, which is negative 22. It says graph f of x. F of x is, so let's make a little table of values. F of x is 5 times 3 to the negative x. So if I'm going to graph that, if I put in 0, 3 to the negative 0, is 1. 3 to 0 is 1, times 5 is 5. If I put in 1, 3 to the negative 1 is 1/3. It flips the 3 over and makes 1/3, so we get 5/3. If I put in 2, 3 to the negative 2 makes it 1/9, times 5 is 5/9. Now let's put in negative 1. So that'd be 3 to the 1, which is 3, times 5 is 15. Let's find those and then see if we need some more points. So if I make each one of these 1, 2, 3, and 1, 2, 3, 0 is 5. 1 is 5/3. 3/3 is 1. 5/3 is 1 2/3. 2 is 5/9, which is about a half. A little over a half. And negative 1 is up at 15, so it's off. And so I've got this graph that's going like this, and it'll have the asymptote. It'll never go negative, and so it'll be something like that. There's f. Explain why f is 1 to 1. Well, f is 1 to 1 because it'll pass the vertical line test and it passes the horizontal line test. since this keeps going closer and closer here, it's not always the same height, it passes vertical and horizontal line test. Determine F inverse of X. So we take F and change the F, which is Y, to X and the X to Y. So we have instead of Y equals 5 times 3 to the negative X, we're going to start with X equals 5 times 3 to the negative Y. And now we got to solve for Y. The first thing we should do is try to undo things, which is there's a 5 times this side. So we're going to divide both sides by 5, and we're going to get X over 5 equals 3 to the negative Y. Now to solve for a power, we take this power equation and write it as a log equation. To what power do we take 3 to get X over 5? And the answer is negative Y. And then to finish solving for Y, we would divide both sides or multiply both sides by negative 1, and we get negative log base 3 of X over 5 equals Y. Now I could use the quotient rule here to break this up into two things if I wanted. This is good enough for the inverse. This is what F inverse of X is. Now I could put the negative up as a power, and that would negative 1 would flip this over, and or I could not. Either way, this quotient could be log of X minus log of 5, base 3 on both of those. But I got the negative of that, so we put a negative there and a positive there. This is just a number. And this I could use to change the base rule if I had to graph this and make it in base 10, so I could make it negative log of X over log 3 plus log of, and I could change base here if I wanted to, log of 5 over log of 3. And that would be another way to write the inverse, and you could actually type this into your calculator and graph it, and we should get the reflection of that, of this original F over the y-axis, which would be something that looks like this. Comes through 5 here, go up here and down here. Be almost the same graph, but not quite. Okay, that was number 1. Let's go to number 2. Find the exact values. So this means don't type it into your calculator. Get the exact values. So this says, to what power do you take 2 to get 1/8? Well, 2 to the third is 8. So 2 to the negative third is 1/8. So we have negative 3 times 2 to the negative 3 is 1/8. So this comes out to be exactly positive 9. Now this says, to what power do we take 10? To what power do we take 10 to get pi? And then we're taking 10 to that power. So 10 to a power and log are inverse operations. They cancel each other, and this becomes just simply pi. And same idea here, ln base e. So what power do we take e to get e to the square root of 2 times the square root of 3? ln and e are inverse operations, and we get 2 square root of 3. They cancel each other and you just get that power. And that's number 2. Those were the easy ones. Okay, that's page 1.